All right, let's take a look at chapter 1. A little bit of information I want to draw your attention to, again, in an effort to help you out. Let me share my screen. All right, so this is from the PowerPoints. As you can see, there are the PowerPoints on your screen. And I'm going to bring this into focus a little bit. They do talk about, and they have to, this is the academic portion of this, they have to talk about some of these things that really you don't see very often. So first off, I want to start here, an introduction to operating systems. This is 2 of 3. What is this operating system doing for us most of the time? In other words, why are we using it? Again, you have this hardware, and this hardware sitting there, or whatever it is, your phone or your PC or your notebook, whatever it happens to be, you got the hardware. How do you use the hardware? Well, the operating system is going to help you use that hardware. It's going to help you manage that hardware and help you do what you need to do. And a lot of that's going to be storing your own data, retrieving your own data, and being able to use certain apps or programs that allow you to accomplish the tasks you need to accomplish. So part of that is the user interface. How are you interfacing with the system? And there's different ways to do that. This is a GUI that's in front of you, a graphical user interface. You're going to learn about a lot of CLI, which is command line interface, where you have to type commands and make sure everything's put right in there. And then there's menu-driven interfaces. You see those on the older TVs, and you see them on projectors, that kind of thing, where it's menu, 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 menu. And that's how you select things. So there's different types of user interfaces, but predominantly what we're dealing with is graphical user interfaces, and then also having to deal with command line interfaces. Storage management, the file system. Again, you're going to be doing a lot of storage of your own files, accessing them, saving them, modifying them, storing them. And so the operating system helps you do that. And then there's also process and service management. Sorry, not server management. Service management. And these processes and services that they're talking about are kind of the integral network of what's happening in the operating system in order for you to be able to say, get on the internet. There's services that provide TCP/IP that allow you to access the internet. And so those are all not buried in the operating system, but they're all working inside the operating system. And you'll do some labs that'll take you into where those services are and what some of them are doing. This portion really gets down to a lot of troubleshooting computers when they're not behaving properly. Of course, there's memory and input-output management. That's what I/O stands for. So this is not a 1 and a 0. That's an I and an O. Memory and I/O management, or I'm printing over here, or my mouse is moving, that's input-output. And where is this stored in temporary volatile memory? That's what we're talking about. So when you talk about storage, you're talking about non-volatile memory, where you're saving something that hopefully is going to be there for years. And this kind of memory is what's on the screen. These PowerPoints are stored in volatile memory. You can see them because they're stored in volatile memory. If they weren't, the computer would have no way to access that, right? It has to have that memory location because it's processing data in the CPU, and then here's the result, right? Where is that result going to go, right? In the olden days, they still had to have RAM, or random access memory, some kind of tape storage, something that was going to allow them to display something. Back then, that you're right, you just print it out. So process, print, right? Not a lot of memory, just some temporary storage memory. Anyway, and then these days, security and resource protection, that's become a big thing. Used to be, we didn't worry about it because we weren't interconnected with our computers. And now the OS has got to keep you secure. And there's a ton of stuff it's doing. And you might think in your head, well, virus scanning and malware protection, all that. Yeah, that is true. But the operating system itself has a bunch of stuff built in to try to keep you secure. And then they want you to know this term, kernel. That's the way it's been spelled historically because of a misspelling a long time ago. But it's come out to mean something, right? When you think of a kernel, you think of a kernel of corn, you think of the kernel at the heart of the matter, right? The kernel is the heart of the OS. As a matter of fact, in many, many, many writings that you may read later in your life, the kernel is the OS, in that all the services and processes are things that are built around that kernel. So again, we tend to think of, I'm on Windows 11 here, and this is part of the Windows 11 operating system. And in some writings, it'll say, no, Windows 11 is this kernel. And this is actually another program called Windows Explorer that's actually displaying this information for you, right? So know that the kernel is the heart of the OS. That's the thing. And then these broad categories of having a single tasking operating system, a multitasking operating system, single user or multi-user, right? What we're dealing with today that we're normally dealing with are multitasking operating systems that allow multi-users to be on them, meaning I can create another user account and log in as somebody else. Not a problem. Multitasking mean, hey, I'm recording a video and I'm moving my mouse around and I can also play some music, right? You can do a lot of multitasking as well. And then the general purpose, which is what we're using, right? So I'm using a multitasking, multi-using user general purpose operating system for whatever I want to do. It can do a lot of different things. A real-time operating system, you'll only deal with that if you actually go into a situation where you're supporting an industrial complex, right? And the robots are being controlled and they have to do something at each individual second, right? You got this whole assembly line going. You can't just all of a sudden say, well, I'll get to that, right? The operating system cannot say, I'll get to that in a minute. It has to get to it in real time, meaning in our time. If when it's programmed, it has to basically say, in 10 minutes, I'm going to do this. And guess what? In 10 minutes, that happens, not 10 minutes and a split second after. 10 minutes, it does that. So these types of operating systems, we don't normally interface with or even fix. It's something that's a lot more particular, but you could end up working with those. You could end up supporting those. But again, that's an example of where they would be. Assembly line is a good example of where a real-time OS would be. All right, so another term probably ought to bring out is embedded system. That's a computing device designated for a specific task and uses a single tasking OS. Good example? Almost everything. I'm not joking. Almost everything. If you have a projector, if you have a TV, right, that has an embedded system in the television and it does one thing, right? And as a matter of fact, a lot of televisions these days are actually multitasking, but more rudimentary stuff is single tasking. It does one thing. So if you got an old voice recorder, I mean, you click the button, it's still digital inside. It's still using all those chips, but it does one single thing. Lots of the new IoT stuff, control your lights, control the garage door, that kind of thing. That's all it's doing. It's not doing anything else. You're not doing word processing on your camera. It's only doing one thing. Cooperative versus preemptive. Cooperative is what we used to use. There are some OSs still out there. Preemptive is what we use now. So every OS that you deal with in a general situation, like you're going to use Linux, Fedora, Mac OS, iOS, Android, they're all preemptive multitasking, meaning that the operating system has control over what programs are doing and when they're doing it. And normally it's going to let them do what they need. But it being able to be preemptive means that, oh, that one's locked up and it's not letting go of the video card or the RAM. So I will chop its head off. I'll kill it so that the other programs can do what they need to do. Where cooperative means that the operating system didn't really do that. It was just like, hey, you guys all cooperate. And then when something would go wrong, it would usually cause a big error. So we don't really use that too much anymore. And it goes into those in more detail. And there we are at the end of that. Oh, all right. Yeah, let's talk about a client OS as opposed to a server, because they are different. And that's where I'm going to end it for this chapter. So if you have, again, if you have questions, you hit something and you're like, I don't get this, you need to be talking to me. Send me a message. I may video you back, or I may just type that out, or we may set up a schedule and do a Teams meeting or a Zoom meeting or something. So I don't want anybody thinking I'm just alone in this. If you feel alone in it, then that's just because that's what you're doing. You're making yourself alone. So please contact me. All right, so client operating systems, that's what we use, right? Desktop operating system, this is a client operating system that I'm using. A server operating system is designed specifically to do things for a server. There's Mac OS server, Windows server, as I said, huge within business organizations. Linux servers, huge within websites, dealing with hosting websites, DHCP servers and DNS servers. This is a lot of stuff that's internal. Microsoft deals with that stuff, but the server operating system is different than your standard desktop operating system. Now, that doesn't mean you can't take a desktop OS and have it do some server things. You definitely can do that. But from the design standpoint, what they're doing, and this is what Microsoft has done, they're using the basic same shell as Windows that they've created, but they're basically saying, you know, this has to pay more attention to the network card or to the storage adapter than a standard general purpose computer needs to. And so we're going to make sure that there's things in place to optimize that, to make sure that it will be running right. Server operating systems will take a long time to boot. There's a lot of checking that goes into making sure that it will be up and running for as long as it needs to, and that it's not going to have a problem where you're like, oh, I better restart my machine, right? So server operating systems are really focused on hosting out files, hosting printers, hosting web pages. They're not set for me to sit down and browse the network on there or browse the internet on. And so they give you some example like Windows Server, Mac OS Server, Unix, and of course, all the different versions of Linux that are out there doing the same thing. So that's it for chapter 1. Again, if you got questions, let me know.